Let's start recording. So find the absolute minimum value and absolute maximum of g on the interval. So the AP test does this a lot, where they give you one graph, call it f, and g is a different function that's related to the graph. So if I look at g here, let me go ahead and edit this. Look at g. G is this integral. That means starting, oh crap, stupid. Screenshot. I actually have an unlocked version of this. I had to unlock them, but I don't have them out with me right now. But whatever. How did I do this before? Done? I forgot how I expanded it. Oh, whatever. Okay, whatever. We'll deal with it. Okay, so starting from 2, right? See the number 2 here? We're going to go all the way to x. And x could be a value on the right or to the left. So an integral means cumulative change. Starting from 2, if I go to the right, we're going to add up values to the right. And going to the left, we're going to subtract values to the left. Okay. So the question is saying, find the absolute minimum value and the absolute maximum. So to find minimum and maximums for us, we usually look at the first derivative. That's one way. So if I say the first derivative of g, so we take g prime, that's going to be d over dx, the integral of 2 to x f of t dt. Now what happens to a derivative and integral? They cancel each other out and we just get f. So g prime of x is the same as us just looking at f of x, the graph. Now, whenever we're looking for min and maxes, we're looking for critical points, because critical points is when things change on us, whether we have a max or a min. So the critical points here are when the derivative, which is g prime, which is f the graph, when is f the graph 0? We have zeros at 6, we have 0 at 2, we have 0 at 10, and maybe even, let's say, -2. That's when the graph is 0. So find the absolute minimum and maximum values. So we're looking for, if I just draw this, we said we have zeros at 2, 6, and 10. I say that. And then the slope is a positive value to a negative value to a negative value. On the left side, that's going to be a positive value. And at -2 here, we have a negative value. Okay? So at what points do we have the slope change from a positive to negative? Because that's what I'm looking for maxes, right? Maxes are when the slope changes from a positive to negative. Right. So the slope only changes at -2, because we went from negative to positive, and at +6. How do you feel about that? Seems somewhat familiar. Okay, so reading the question one more time, find the absolute min and max value of of g. To find that, we take the derivative, and the derivative turns out just to be the function f. Because our fundamental theorem of calculus, our derivative and our integral cancel out, just plug it in. So our derivative is just the function f. When we're looking at the derivative, we want to find when, in this, normally we have to consider the endpoints. But let's see. So if we look at -2, okay, we said this was a max or a min. We said this was a, we go from negative to positive, so that's going to be a minimum. So a minimum at -2. So I think in the previous parts of the problem, you might have been able to find out what the actual value there is. Because when they asked me find the absolute, they didn't just say where, they want to know what it is. So if I plug in the integral, what's g at -2? That's going to be from 2 to -2 f of t dt. And then if I want to rewrite it in the left to right way, it's going to be a negative integral from -2 to 2 f of t dt. So what is the area from -2 to 2? That's a triangle with a base of 4 and a height of 4. 1/2 base times height, that's going to be a positive, that's going to be a -16. So my lowest value is going to be -16. And since our slope is coming down, right, we're coming down to it, that means my left endpoint isn't going to be my lowest value. My highest value is going to be at 6. So g of 6 would be the integral from 2 to 6 f of t dt. Looking at that from 2 to 6, we see that's going to be, I forgot to add one thing. What was the actual value at f at 2? So g at 2. G at 2 is 0. Oh, I'm sorry. No, I think we're okay. Oh, sorry. I forgot to divide this by 2. That's going to be -8. And then on the right side, this is going to be 4 by 4. Right? Height is 4. Base is 4. That's going to also give us 8. So that's going to be a +8. So you could, let's see, would I consider the endpoints? Normally we would. So if we plug in values at the endpoints, what is g at -4 and what is g at 12? And when we check our endpoints, g at -4, so it would be, this is 8, this is 4, so this would be we said negative and then positive because going backwards. That's going to be -4 on our left. And on our right, we said this was 8. This is -8, so they cancel out. And then this is a 4, +4. So this would be +4. So looking at our, -4. That's a negative. That's -4. So when you hear the word absolute, we always have to check our critical points. And you're right, we have to check our endpoints also. Because we don't know what happens after the point. Maybe this would make us even lower than our original lowest value, which was -8. Okay, questions about this one? Are we okay with the first steps of first reading it? Find the absolute min and absolute max, meaning I have to look for critical points, which is the derivative of g. To find the derivative of g, we just read it here. The derivative of g gives me the fundamental theorem of calculus, which that cancels out, leaving me just f of x. We can just look at the graph for f of x. To find critical points is when the derivative is 0. We had zeros at -2, where the graph is actually 0, and at 6, as well as 2 and 10. But critical points, it's only a max and min when the sign changes from a positive, negative, or negative to positive. And when I drew my little sign chart here, it helped me just look at the positive and negatives, and we see that we have a negative to positive at -2, and a positive to negative at 6.
I think I honestly just kind of like forgot how to do it when there was a graph and whatnot. But also on the answer guide, it said that you get 1 point for considering the endpoint. So you also have to plug in the endpoint.
Yeah, when they use the word absolute, then as you mentioned, like way back when, like months ago, yeah, you have to consider the endpoints because you don't know. Let's say you start off really high and then you come down the graph, right? And then you do a little bump. Sure, this is a critical point here and here, but we don't know we didn't know that you start off really high, so you have to check those endpoints.
Okay. I think I honestly just kind of like my brain.
Forgot.
Yeah. And then could you do D?
Yes. So for D, we have -4 to 12. Okay, find all the intervals where G is less than 0. Okay, so that means the integral value, when we're adding it up, it'll give us something that's negative. Okay, saw this stuff. Let me actually, you know what? Let me just delete that and redo it again. Oh, full page, that's where the button was. Even better. Okay, so find all the intervals where G is less than -1. Okay, so going to the right, so starting from 2, the integral says cumulative change. So I'm just adding up the parts. If I go to the right, I'm adding. We said this was going to be 8. Then we start subtracting. That's going to be -8. So that gives us a cumulative change of 0. Or it's okay that G at 10 is now 0. So afterwards, we end up with our more negative area. And that's going to be -4. So it's a negative value from x is between 10 and 12. Oops, darn it, that's terrible. Between 10 and 12. Going the other way left, this is where people get confused, and I also get confused sometimes, so I'll rewrite it going left here on the left side. If I write g of, that's right, -2, like we did before, we realize that this would be written as integral from 2 to -2 of f of t dt. Now we don't like going low to high. We rather go, we like the lower number on the bottom. So I'm going to rewrite this as g at -2 is negative, then flip the integral from -2 to 2. So I could count from left to right. And if I do this, this area here, which was a positive 8, becomes a -8, like we demonstrated in our last part C. So we know this is -8. So if I write g at -2, this is -8 right now. What happens here? Are we still going to be negative? Well, this section here is now a positive. So we're going to add and cancel it. So this is 4. So it's not enough to bring it out of the negatives. So g of -4 is equal to 8. -8 plus 4 is -4. So we're still going to be negative. So we're negative from -4 all the way to 2. Okay. So when is this negative? This is negative between -4 and 2, as well as from 10 to 12. One of the things that get me oftentimes when I'm going backwards here, you can say, hey, Ms. Go, that's a positive area. That's true. But because I went backwards, it's subtracting from me. Okay. So another way of thinking about it, we're starting at 2. And let's say 2g of 2 is 0. Okay. So what was g at -2? Well, g at -2 we said was -8. So from -8 onward, don't I add values? We added 8. -8 plus 8 gets me to the 0 here. So what happens is when I'm going right to left, we are subtracting those values. We're going backwards. Because we added to go right, so we're subtracting to go left. I think us writing it in this formula way is actually really helpful because it helps me with the sign determining if it would be positive or negative. And because the order was wrong, I put the negative in front. Put the negative in front. And then that tells me that's going to be a negative area reading from left to right. Okay. Anyone have any follow-up questions to that? Okay, next question.
I had a question on number 5 of this same.
Sure. So number 5 is one of these kind of cone problems, but it's not going to be specifically like a cone. It's a funnel, right? Because it's not straight, it's tapered. So you want to be careful about using your cone formula. And they give us this radius problem here, radius formula, which we're going to use. So the inside of the funnel has a height of 10, okay? So the whole thing is 10. It has a circular cross-section as shown in the figure above, okay? At height h, the radius of the funnel is given by this equation, good. So they gave us a relationship where between 0 and 10, got it? Find the average value of the radius of the funnel. Find the value of the radius of the funnel. So average means we're going to add up all our points. So we add up all the values. So that's probably going to be a integral. And we're going to divide by our range. This is from 0 to 10. So we're going to say the integral, the average is cumulative change, add up all the parts. Okay, I add up all the parts using integral from 0 to 10. Then we divide that from 1 to 10, sorry, 0 to 10, so by 10. Since this is a plus sign there, we can take the integral of them separately. So we're going to write, I'm going to move the 120 out. That's 1 over 200. And then we're going to take the integral of 3, which is 3h plus h cubed over 3. Then we're going to plug in 0 to 10. And we're just going to plug in those numbers. Okay. So that will be 1 over 200, 3 times 10 plus 10 cubed over 3. And then if I plug in 0, it doesn't matter. So if you leave the answer like that, that's 100%. They would give you credit for that. You don't have to say 30 and you don't have to say 1,000. So the key word here is just the average value. So just think about what average is. Average is when I add up all my values, which is what we use the integral for, and we divide by the number, which is our range here, which is 1 over 10. Any questions on part A? Is everyone okay with the idea of an average?
Where'd you get the 1 over 10?
Okay, so when I'm finding the average, it's the integral, that's a to b of f of x.
Mm-hmm.
And then we divide by b minus a, which is the interval.
Oh, right.
So whenever you hear the word average, is you use the integral to add everything up, and we divide by that range, like the overall time. Like you could even say, this equation is how much money I'm making. Well, the integral will tell you starting from what hour to what hour, and you have to divide by the number of hours you worked.
Yeah, I've had forgotten how to set up the average value.
Yeah, so if we look at the cheat sheet, let me see, do I have the cheat sheet here? I feel like the cheat sheet might have the average formula someplace. Calculus integrals. Let's see if the word average is anywhere. Substitution, approximation. I'm surprised the average isn't here. I don't see it. Let me check the other one. the mean quotient chain. No, they don't have the average here. Darn. The average is, I think, on one of my cheat sheets, though, elsewhere. I don't see it here. Okay, sorry about that.
I'm getting socks. You can get also. And then I had a question on B, but I think it was just the setup. And for B, they just did, I think, oh, wait, let me find the answer. Oh yeah, did they just do the integral of the volume equation for a funnel or not?
Let me get there again. Okay.
I just didn't have that.
Part B, find the volume. So I don't think, yeah, that volume, would that be on the test? No, because volume is our last unit. So no, if you wanted to do it, so to find the volume of this, remember we would just do little circles. So we do something like an integral from 0 to 10, and then we would find the radius and go pi r squared, where r is 1 over 20, 3 plus h squared, and then dh.
Yeah, I completely forgot about this, but this isn't going to be on the test, right?
No.
Okay.
Letter B will not be on the test because volumes are, well, when it comes to shapes where we spin around, remember we have disc and washers. Those are unit 8, which are not included on the test.
Okay.
But really, that's the formula that you would use and you're done. Okay. The funnel contains liquid that's draining at the bottom. At the instant when the height of the liquid is 3, the radius of the surface is decreasing at. So the next one, yeah, that one's on it. So this is, I feel like, a related rates problem.
Yeah, I was able to do the next one, but if anyone else needs it.
Did anyone need help with a 5C? I know Ms. Yagi's class like barely covered it with me in like a day. So I'll go ahead and do 5C, which is a related rates question. So the funnel contains liquid that is draining at the bottom, right? Draining. At the instant when the height of the liquid is 3 inches, h is equal to 3, and the radius of the surface liquid is decreasing. So radius decreasing, that's a rate. So dr over dt is equal to negative 1 over 5 inches per second, And that does make sense because dr is a radius and dt is a time. So it's inches and second. That kind of makes sense. At this instant, what is the rate of change of the height of the liquid with respect to time? So they're saying, what is dh over dt? Okay, so the hint here is that when you write out dr dt and you write out dh dt, you realize I need to find the derivative of r and h. Well, looking back, they gave me one equation that has both r and h. So all we have to do is take the derivative of that. If I take the derivative of r, it's dr over dt equals to 1 over 20. That's a constant. And then we have to take the derivative of 3 plus h squared, which is 2h dh over dt. Let's look at again why. 3 is a constant, goes away. And the derivative of h, sorry, that's the base of t, okay, is power rule. Bring down the exponent first. Becomes a 2 in the front, h, subtract 1. And then what's the derivative of the chain rule inside is dh over dt. And it's a 1. It's a 1. So cool thing now is that we're solving for this guy here. We know what h is, and we know what dr dt is. So this is as much work as you're required to do. Negative 1 over 5 equals to 1 over 20. And plug in the 3, dh over dt. And we want to solve, because they asked us to solve for dh dt. And we just kick everyone else over to the right. We say negative 20 over 5 and divide by 3. And that is your answer. Did they tell us to write the correct units? At this instant, what is the rate of change in the height with respect to time? Yeah. And dH would be inches per second. Okay, for those guys who just joined, we've covered, I think, 2 questions so far. And if you want, I'm going to put this on YouTube. You can catch up with the rest if you need it. But we just covered questions, in this case, questions number 3 and 5. On the cheat sheet, average, oh, it is written, average velocity, average acceleration. Oh, calculus and motion. Yes, that's in my other cheat sheet. And I think the motion stuff is valid. But the average value of a function, that I'm not sure if it's valid. I don't think that's valid because I think that's unit 8. Now that we don't know how to find averages, we know average rate of change. That's a keyword. Average rate, which was f of b minus f of a over b minus a. Thank you, Penelope. Any other questions on this? I can continue or I can move on. Hopefully you guys, this is always a funny one when they give you a table.
I have a question on part C for this one.
For this last one? Sure. Number 6. Anyone have any questions for A or B? Let f be continuous and have second derivatives. So we see the first derivative and then we see the second derivative, okay? The table above gives values for the function and the derivative as selected intervals. Good. It pretty much tells us everything we need to know. The first part, just to say, if k is a composite function, write the equation for the tangent line when k of k at x equals to 3. So to find the tangent line is y minus y1 equals to m, x minus x1. So to find m, that's the slope. So what's the slope? We take the derivative. The derivative of this guy here, we need chain rule. Derivative of the outside, leave the inside alone. Multiply by the derivative of the inside. And they told us x is 3. So f prime g of 3, g prime of 3. And that's going to give you some value. So we look at the graph on top, the table on top. G prime at 3 is 2. G of 3 is 6. And then we have to find on the table what is G at 6. So G prime at 6 is 5. 5 times 2 is 10. So we know this is 10. We know X is 3. And the only problem is finding that Y value, which is, if I plug in what is F of G of 3. And again, you look at the table, G of 3 is 6. And F of 6 is 4. Y minus 4. That's our tangent line equation. I'm just giving them what they want. I'm not overthinking it, but I'm looking back at a lot of algebra too. The second one, find the derivative. That's going to be quotient rule. So we just derive the top, leave the bottom alone, minus derivative of the bottom, leave the top alone, over the bottom squared. Oh, let's not write that way. We're just going to plug in the 1. Now, right, the last one, evaluate. This is I feel like a fundamental theorem of calculus, maybe rule. And we know an integral and a derivative, in essence, cancel each other out, right? They should undo each other. So, let me think. What's another way we could explain this? Because since I know they do cancel each other, we're going backwards. So this is essentially, let's look at another example, okay? If I write f is equal to, no. If I write f is equal to the integral of little f. Okay, let's write that as an example and call this A and B. Oh, sorry. Then the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. You guys are cool with that part, right? That if I want to find the integral, we just write what that integral was. So the integral of f prime is, sorry, f double prime is just going to take us back to f. So this would equal to f prime of 3 minus f prime of 1. Wait, sorry. Plugging in that 2 there. But then our stuck here is this point here. And that doesn't follow our rule here. So this is where we do that u sub trick. So if u was equal to 2x, du is equal to 2 dx, dx is equal to du over 2. That means we need a 1/2 in the front. We need that 1/2 in the front. So we have 1/2 in that overall problem. Okay. To talk about this again, just a reminder, this rule here, to get to here, works because that's x. Now, if you want to deviate from that at all, like they gave us 2x, right? So you could always swap it and say, no, u is equal to 2x again. So it's going to be f double prime of u. And we're going to change that dx to du over 2. And then we can use that rule again.
I think I got confused. So an integral is just taking us back a derivative.
Yes.
So we just do
So if you remember this rule over here on the right side, this is for definite integrals, where I do give you the a and b value. If there was no interval, if it wasn't a definite integral, we would always write plus c to it. But if you do have an a and b, we just write the integral, and then we plug in the b minus the plug in the a.
Oh, I see. Okay.
So for here, we could get from double prime back to a single prime, because that's what it does. Except this 2x is what messes us up. And then if you remember, if it doesn't look like the rule, we can do u substitution. And that's what the gimmick here was. And this would be 1/2 f prime of 6 minus f prime of 2. And we can look at the chart for those values. Again, for these questions on this test, a lot of it was just reading the directions and then making sure you catch those like tricks. The trick here was that the integral of a derivative should take me back. So we're thinking f double prime should take me back to f prime. And the gimmick here was, don't forget the 2x would make us have to do u substitution. Very similarly, if I wrote sine of 2x dx, we said we don't know how to deal with that 2x part. So what we do is we say u is equal to 2x, then du is equal to 2 dx, and then dx is equal to du over 2. So when we rewrite it, it's integral of sine 2u du over 2. Yep, sorry, there's no 2 here. Sorry, I'm laughing at my kid in the bathroom. Any questions on this one? I can clarify or redo the problem if you need me to. Or whatever you need, guys.
So we didn't have to change the boundaries because it was just 2.
You could, but I think this is an easier way, just doing the use of and then plugging back the original value back in.
Yeah, but I'm saying we didn't have to change the 3 and 1 to like something else once we did use sub.
You could, like if I didn't want to plug in the 1, you could have swapped like the 3. You could have changed the interval. You could have.
But we
if
didn't
you
have to.
You know you didn't have to. Because you would still have gotten a 6 and a 2 here.
Okay, that was my question.
Yeah. Like I wrote 3 times 2 and 3 times 2, but you don't have to do that, right? Usually I like plugging back in my u value, but if you want to keep it as u, we said u was equal to 2x. So if you plug in the 3 and you plug in the 1, 3 times 2 is 6, which is where we got here. And 2 times 1 is the 2.
Yeah, so it doesn't matter in this case.
Doesn't matter. What happens is when you switch your, if you want to switch to u or keep the x, it's literally the same amount of work.
Oh, so we never have to do that.
No. If you want to always go back and plug u back to your x version, do it, because it's the same amount of work.
Yeah, okay.
If this was if this was a multiple choice, sometimes they'll give you the multiple choice question where they will leave it in u form. So you had to be aware that they left in u form.
But that doesn't matter.
No, that doesn't matter in our case, not this year.
Cool.
Okay. What else?
I have a question on the 2017. I
Sure.
feel like I'm asking all the questions.
You know what? You are the voice of the people. Great job.
Oh, thank you. Okay.
And that's my little boy, being the voice of the toilet.
Wow.
Everyone's got to represent everyone.
2017, and then number 1, part D.
Sure. Let's take a number 1 part D. Let's see if it's a calculator, non-calc. Number 1 generally is a calculator. Number 1 and 2 are calculator questions, but they're not always. Every question is a calculator question. That's why.
Could you go over the setup for D though? I think
Sure.
you might need a calculator at some point, but
Could you do the first parts for 1 also?
Sure.
For this problem? Thank you.
Let's go through it. So for the first part, thanks to you guys who actually went over these practice tests. They are challenging and they are confusing, but that's part of the process, unfortunately. Okay, a tank has a height of 10 feet and a horizontal cross-section of the tank at height h is given by a function a, where h of a is measured in square feet. The function a is continuous and decreasing as h increases. Select the values for HA are given in the table above. Okay. Use the Riemann sums, left Riemann sums, to find 3 subintervals indicated by the data in the table to approximate the volume of the tank. To talk about volume, volume is equal to area of the base times height. Okay, to give you a picture of that, it's area of the base, and we multiply it by some height, gives us the full volume. Okay, so the base here is 50, the height is 0. Then the second base is 14.4 and the height is 2. And my third base, 6.5 and 5. So that's all we do. Riemann sub says multiply, and then by the left value, not the right. So it's, sorry, my kid's running around. The volume is equal to 50, oh my gosh, it's scary. 50.3 times 0, that's a free one. And 14.4 times the 2. And then plus the 6.5 times the 5. That's idea Riemann sums. Wait, oops, my bad. That's wrong, that's wrong.
That's not right.
I make a mistake always because like the base value, sorry, this is the length of the base. Oh my gosh.
Yeah.
We use this value. I went the wrong way. So the base there is 2. We'll multiply that by 50.3. I'm sorry. And then the next section right here, this is my next section. That's going to be a 3, right? 5 minus 2 is 3. Multiply that by 14.4. And then the next section in feet, that's 5 to 10. 5 times the left value, that's our y value. Sorry. If I want to look at, if you draw a little chart for yourself, it might be a little easier to see. 0, 2, 5, and 10. The left value, that's like 50, then 14, then 6, and then 2.9. And if you look at it this way, it makes it a lot easier to realize. So my left interval, my left interval, my left interval. That's why it's 2 as a base. That's why it's a 3 as a base. And that's why this is a 5 as a base. Sorry about that. And the units, since I'm multiplying it, it's going to be feet squared by feet is feet cubed. Any questions on that? Okay. Does approximation in part A be an overestimation or underestimation of the volume? So we know we're decreasing, so values are constantly dropping, right? So since we're choosing the left side, does that look like an overshoot or undershoot of my actual graph probably? And since we're decreasing, every starting value is always bigger than your ending value. So this is going to be an over approximation. And the calculus way of explaining this is because this is decreasing, because the area is decreasing, we would get an over approximation because we chose the left Riemann sums.
I found a rule, and I was wondering if you could tell me if it's correct. It's basically what you just said, but it's like if the graph is increasing, then left sum is an underestimate and right is over, and then if the graph is decreasing, left is over and right is under.
Yeah, because like naturally, it's exactly what I said. If I'm losing money, my starting value will always be higher than my ending value. So the left Riemann sum will always be bigger than that right Riemann sum. Or it'll be always bigger than the graph overall. If we are increasing, the left value will always be smaller than what the actual graph is. Always smaller than the actual value of the graph. But yeah, the rule that you read is right. But it's also like intuitive, like if you look at the graph. Okay. Part C, the area in square feet of the horizontal cross-section at the height. Okay, that's decimals. Yeah, that's going to be calculator. D, the water pump is pumped into the tank when the height of the feet is 5 feet. The height is increasing at a rate of, okay, so dH dt is equal to 0.26 feet per minute, a foot per minute. Using the model in part C, darn it, the model in part C. Find the rate at which the volume of water is changing with respect to time. So
the model in part C is just like an equation.
Just an equation, right? So dV over dt, find the rate at which the volume of water is changing with respect to time when the height is equal to 5. Indicate the value it measures. Okay, area and height. So to find the volume, it's going to be, the area in feet squared of the horizontal cross-section of h in feet is multiplied by the function. Okay, so that's our area equation. So to find volume is equal to our F of h times h. All right. Part D. They do it. They wrote it as the integral from 0 to h of adding up the areas, which is f of h dh dt. No, sorry, tx. That's what they wrote.
Where did the x come from? Their method was confusing to me.
Their method, the reason why they wrote x is because you can't use the same variable twice. That's the only reason why. You can call it whatever variable you want. It's just that this function is going to change from 0 to h. So we just don't use that same variable. You can pick any variable you want. You just don't want it to be the same variable outside and inside. So they said, if that's the area, we're going to find the volume. Kind of similar to what I wrote. Similar. Let me think. But then what they said is, you take the integral. I see what they want. The problem is, they said here, they separate it to become dv over dx times dx over dt. In this case, they don't use x, they use h because they need the variable h. Sorry. We have dh over dt. We just need dv over dh, which is the derivative of their equation. So we take the derivative. I think they want h, yeah? The integral of 0 to h of f of x dx. What happens to this derivative and this integral? They should cancel out, leaving you f of h by itself. So they're saying that this here is equal to the derivative of v, we said was going to be f of h, and then dh over dt. And then they said, okay, the value of h is 5, so plug in f at 5. And we know what the dh dt at 5 is 0.26. And then you plug the 5 in, and you get some decimal. So I think the hint here is that to find the volume, they took a sum of the area problem from 0 to h. They said this is v in terms of h. But their question was not v in terms of h, but v in terms of t. We could separate our slope instead of writing, our derivative, instead of dv dt, you can make up a variable to stick in between there. An example is if I write 5 divided by 3 can be written as 5 divided by 2 times 2 over 3. You can put whatever you want here. They chose specifically that they needed an h. So they plug in dh dt. And one hint here is right here. See, that's a dh dt. They wanted the dh on top. So these are always tricky ones because we don't see them very often where they have you split up that derivative. Okay. Yeah, this last one would have been a tricky one. So let's go back and look at some key points. The height, water is 5, increasing at rate per minute. So that's why we wrote dH dt. There's no mistake there. From part C, we're given a problem that this is not in relationship to T, this is in relationship to H. Find the rate of volume as the water is changing with respect to time, the height. So they said the volume is the sum of the area. So they just took the area times a little bit of height, which I think that was the equation for part C. They then said find the find the rate of the volume of water with respect to time. They said find dV dt. The problem is if you look here, there's no dV dt. So instead they broke it up and said, hey, I don't have dV dt, but I do have dV over dH, because if I plug that in, that's going to be H value, right? That's going to be H value. So they separated it. We had two slopes now, two derivatives, sorry. This was given by taking the derivative right here, fundamental theorem of calculus, which told us that our V over dH was going to be f of h. We were given up here dH dt, which was 0.26, and then we just plugged it in. Okay. Next question. Or any clarifying questions on this one?
So your key sign that you had to do dVdh and then dH dt was because the equation in part C was f of h?
Yeah. Like what happens if you did try to take the derivative of this guy? This would call this volume, right? This would be dV over dH, which is not what we have here.
Oh, okay.
Because they asked me for dV, they specifically told me with respect to time.
Yeah.
But the equation they gave us was not time. If they gave us f of t, great. Like let's say it was 50 over e to the t plus t, right? See, that's a t equation. We'd be good. But they didn't.
Yeah.
So we then had to change it.
Okay.
Which is not something you catch right away. You're like, maybe I wrote it wrong. But that's the trick.
Is f of 5 6.5?
F of 5 is, they told me it's gonna be 1, no, actually not.
Oh, is f of 5, you would plug it into the equation
On top, the 50.3 divided by E,
Got it.
and because the height would be 5, we just plug that in there. So if they do give you a question like this, the integral of part C would be easier, and you wouldn't need a calculator, and also plugging it in would be easier. So no calculator would be needed. But of course, you're allowed to use a calculator, it's just not required.
So could you have just left it as 50.3
Yes.
over e to the
Yep.
0.2 times 5 plus 5 times 0.26?
Yeah. So if you just leave it without plugging in, that's actually okay. They don't care about the arithmetic part of it.
Could you do number 3 on this effort on 27?
Sure. The graph ones are always tricky because you have to orientate yourself because every graph is different. Now to look at this graph, they told us f prime is my suspect here. So we know that's the derivative already. Whatever we're gonna do in the problem, that's already the derivative. So remember, if that's true, that means this is a positive slope, this is a negative slope, This is a positive slope. Also, we have critical points. That's critical point. That's critical point. That's not a critical point. Is it? Let me think. Nope, that's not a critical point. Oh wait, it doesn't exist? No, it does exist there. Yeah. Okay, those are points. Okay. So we do have a change in sign. Just to talk about, we have a plus, positive, negative, a negative to positive, and that's nothing here, right? That just stays positive. Just be careful. Okay, look at the problem. Turn it. Okay, the function of f is differentiable on the closed interval from -6 to 5. That satisfies f of -2 is 7. So this and this guy have, like, don't look at the graph. They're just telling you an initial point if you want to put a nail in the stud. In the original graph, f of -2 is 7. Okay, f of -2 is 7. Here's -2. That's -2 right here. So in the real world, we are 7, and then we start losing value. So 7, then we drop to 6, 5, 4, 3, 2, whatever. We're dropping just to talk about it. Don't waste your time on the test, but just talking about it. The graph of f prime, the derivative of f consists of a semicircle, 3 line segments as shown above. Find the value of f at -6. Okay, great. So to find f at -6, okay. So how to get from here back to here to -6? So a couple ways of doing this. Like, you could just map it out. You could just say that triangle, what's the area of that triangle? Area of the triangle is half base times height. Half base times height. This area is 1, 2, 3, 4. 4 by 2. This area is half of 8 is 4. That's 4. Now, logically, whatever value I start off with, I made money. I made 4, and then I got to 7. So we're adding value. So you could say 7 plus 4 is, I'm thinking 11, right? 7, what would be minus 4? Sorry. Other way around. I just said we added, gosh. So if we are 7 here, and we added 4 to get to 7, we were at 3 here. So another way of looking at it is, let's do it the mathematical way. If I say I started off at f at, darn it, let's try a different way. F of -6 is the same as us starting off at f at -2. And then we're going to add from -2 to -6 of f of x. Well, f of f prime, because you want to go backwards. If you don't want to deal with a negative, we go from low to high. You can write this as a minus, the integral from -6 to -2. We said this here is a triangle. That's a triangle, value at 4. So we would say 7 minus 4 is the 3 we wanted. To get to 5, which is way over here, we started from 7. We're going to add a semicircle and add a triangle to it. The semicircle here is pi r squared, where r is 2, so it's 4 pi. This is a triangle, base of 3, height of 2, so 6, half of 6 is 3, so 7 plus 3 plus 4 pi, which is 10 plus 4 pi.
It's 4 pi over 2 though, isn't
Oh,
it?
whoops.
Semicircle.
Sorry, we divided by 2. Thank you. And then that's a positive or negative. I made another mistake here. I'm sorry. That's a negative circle because it's all negative. So we're going to subtract. So -2. I'm sorry.
Why is it the
7 plus 3 is 10. I'm sorry, what?
why is it the integral of f prime?
Oh, because the graph that we're given is f prime, but they want f. They want you to go backwards. So to get from f prime to f, we take the integral. We add up all the changes. That will give us back to f. So if you, I think of another way to explain it. So this graph here is all our changes, right? So if I say I start off at 3, that's the real world, 3, and I add up all our changes, which was 4, that gives us our new value 7. So what happens is when we're taking the integral, because that's sorry, my laptop, my Zoom crashed on the tablet. Let me reset that. Give me 1 second. So when it comes to the integral, it takes us back to f because we're talking in that f world. You gotta get back to f. That's what the integral is for. Oh, come on. Hear myself. Okay, back to it. I lost it. Okay. Okay. Everyone still here? Okay. Let's move on. So the next part of it. Was it Maya that asked the question or
Olivia.
Olivia? Sorry, Olivia. Olivia, were you okay with the integral part or are you still confused about the integral?
No, I think I got it.
Okay. Because to get from f prime back to f, we have to take the integral.
Mm-hmm.
Okay, on what intervals are increasing? Increasing specifically is when f prime is greater than 0. So since this is f prime already, those are positive. That's positive. F prime is greater than 0. That's why it's increasing. That's it. Easy as that. Whether you do this or this, it doesn't matter because 0 is neither a positive or negative. Okay? So I've seen it in both. Find the absolute minimum value for f, and then on the closed interval from -6 to 5, okay? So the whole graph, -6 to 5. Do we have a minimum? So we have a minimum and absolute, so we have to check the endpoints, okay? So be aware. Oftentimes you'll see on the scoring guide, they'll have a table of x's and f of x, the graph. So careful, they want us to find the value of f, right? So we're going backwards. So we already found that at -6, our y value was going to be 3. We already found at 5, our y value was going to be 10 minus 2 pi. We found those already. and we just have to check the critical points. And we want to go from a minimum, so a negative to positive. So minimum goes down to positive. So we have a minimum at 2. So what would that be? That would be starting at 7 minus, we said that was 2 pi. Okay, and that's it. For D, for each f double prime at -5 and f double prime at 3, find the values or explain why each does not exist. Okay, so at -5, 1, 2, 3, 4, 5, and f at 3, 1, 2, 3. Okay, so why do they exist or not exist? If I look at the derivative of this line at -5, well, it does exist. And the slope is going to be rise of -2 over 1, 2, 3, 4. -2 over 4. So this one does exist. The second one, at 3, it doesn't exist, the derivative, because it's a corner. So oftentimes what they'll do is, since the slopes don't exist, but what they do in the answer sheet, they said f, the limit as x approaches 3, and they just do the rule f prime of x minus f prime at 3 over x minus 3 from the left side versus the limit as x approaches 3 from the right side, f of x, f prime of 3 over x minus 3. That's the slope equation. So the right slope equation and the slope left equation are not the same slope. So, okay. All right. Next question.
This FRQ is the farthest that I've done so far, but I mean, I don't doubt that I'm gonna have questions on like all the
Sure.
other ones.
Um,
What would you like?
I can do another Zoom at, trying to think,
What
at
would
7.
you recommend we?
I think looking at the answer sheet is really helpful after you've tried it. And what happens, they'll give you like a hint to like what they're thinking about. And that's kind of like where we're at. We're taking practice tests, so we're not totally shocked when we see the real exam. And there are ways that they write that if we didn't practice, if we didn't read it before, it would be confusing. So I think you guys just going over the practice test and then maybe like giving yourself a couple minutes and trying it again yourself, I think that would be really helpful.
How difficult would you expect the exam to be compared to these questions?
About the same. I don't think they'll be any harder than this, because free response questions are already pretty hard, and like just because you're taking it home doesn't make them any less hard. So this isn't like a college where they're trying to like pin you to a wall. Oftentimes colleges, if you take a take-home test, like a math test, it will be a lot harder because they're thinking that you're going to find help from friends. So they don't want you to get away easy. So that's what colleges like to do, and they're kind of okay with that. The College Board is kind of, I think, in a corner where they're just trying to get you to demonstrate that you know the material. And the way they're like sticking you in a corner is by giving you only 25 and 15 minutes for this test. So the time crunch is what's killing you. So let's say you look at a question and you don't know how to do it. If you go back and look at some practice tests, by the time you look at those practice tests, you've lost time. You probably won't be able to finish the test, but you'll get some points. But I think the difficulty should be about on par with these practice tests. The key thing is always spotting that key word about what to do. Like when you hear the word increasing, you're thinking about derivative. You think about, like some of the keywords that we just saw today, right? Like Riemann sums, we have to know how to do that already. Approximate, overestimate, underestimate, find the values, reading the graph. This one, look, part B, find the second derivative. Can you find the second derivative of that? You just gotta get to it. Tangent line equation A, right? These are all like keywords that once we see it, we know, hey, I gotta get hopping. So will it be harder than our regular like free response questions? I don't necessarily think so. But free response questions are already hard already because they're giving you key like clues about what to do, and if you don't know what that clue is, it's hard to figure out which way, like how to start the problem. But for the most part, the stuff that we've done isn't like the math isn't hard. It's just like getting started is hard. Hey Taylor, welcome.